Okay, on this question, we have the natural log of the square root of that big old fraction. I mean, it looks terrible. They want us to take the derivative, and they give us this very important hint. Hint, before you take the derivative, expand using the three log properties. Well, I don't know if you remember all those log properties, but well, let me give them to you. So the log properties up here. Log properties number one, the log of x times y multiplied is log of x plus log y. Multiplication, one log becomes adding for two. Um, Second one is log of x divided by y is log of x minus log y. And the third property, you might remember from pre-calc, is log you have x to a power, like that. That power can come down to the front. And it sits there in the front, p times log quincy x, like that. I scribbled that, but you get it. So those are the three log properties. So what I'm going to do is I'm going to do this one first. Bring that power down. And ln, by the way, is just a type of log with base e. So it's gonna, these rules are for any log. So that includes natural log. So the first thing, yes, they say expand or rewrite. So I'm going to rewrite. There's no derivatives yet. This is still f of x. Going to rewrite. Going to put that half in the front. And then we have ln. Now, these two things are divided. And what does dividing do? Becomes subtraction. So it's going to be half. Now you gotta put half like that. And ln of 8x plus 7 minus ln of 9x minus 4. In fact, let me just for added clarity here, let me put parentheses like that, just to the colors help. Do you see that? Do you see why it has to be that way? So again, the powers can come down to the front. That's the third log property. Got that. And then these are divided. So you have dividing. You can make that two logs subtracted, but they each have to have their own set of parentheses. And what if I left this? You might wonder, why do you need this? But what if you left this half off and just had like that? That would mean the half is only multiplied by this first log. It's not multiplied by the second. And that's wrong. Why? Because the half was the power for both of them. Therefore, when it comes down to the front, it becomes the multiplier. It has to be the multiplier for both of them. This way, the half is understood to be multiplied. But I'm not going to actually distribute it. I'm just going to leave it in the front. You can see it's part of the final answer to sit in front, but it means it's really multiplied by both. And that's what matters is the meaning because it was the power for both. Now it's in the front, multiplying both. Okay, anyway, now that's the rewrite. Now I'm going to actually take the derivative. Now that I've done the rewrite, I expand. That's what it means by expanding them using the property. I never used the first property, didn't need to. I'm going to take the derivative now. So that first part was a rewrite to make the derivative easier. Now comes the actual derivative. And the half is just going to sit there because anytime you have a number multiplying the front, it just sits there. Put these parentheses here. And then I'll say, okay, how about the derivative of this part? Now, how do you take the derivative of natural log of anything? The derivative of the natural log of anything is 1 over that thing, huh? So this will be 1 over 8x. It's not the neatest. 1 over 8x plus 7. But hold on, that's not all. Yeah, it is. That's the rule. It says right there, natural log of anything, you put 1 over that thing. Right, but what derivative rule is always part of every other derivative rule? Chain rule, right? If the inside is anything other than a simple x, you can't forget to multiply by, according to the chain rule, we got to take the derivative of 8x plus 7. That's just going to be 8. Right? Because derivative of 8x, that 1 just comes down, then subtract 1, it's gone, the 7 is just 0. So it's not big, but don't forget it. Minus, now it's the other guy's turn. What's the derivative of this guy? Well, again, it's going to be 1 over the argument. But because the chain rule's here too, chain rule derivative times the root of the inside, which is just going to be 9. Like so. And that's really the answer. They just put the 8 on the top because 8 over 1, you could just stick it on the top, and the 9 over 1, you could just stick it on the top, and that's how they did it. But we did it. So notice it made the derivative actually not that bad by doing that rewrite. By the way, if we didn't do that, this would have been horrible. I mean, I'm not going to show you. You can go to Offstars if you want to see. But if you were to try to take the derivative of this, um, it would have been awful. You might be thinking, no, wait, Mr. It's not that bad. You just well, what will be the derivative of natural log? It's 1 over this whole thing times the derivative of this whole thing, which is a power and a fraction. Quotient rule, power rule, log rule. Oh, it'd be awful. It'd be awful, awful. So in this case, logs made it easier. We just did the log properties. We brought down the half, the rewrite before we even did the derivative. Just brought down that. So you want to know these 3 log properties, put them on your notes. Bring down the half, and then dividing becomes subtraction for the 2 logs. Then you see what's easier. Why is it so much easier now? We separated them and they're just separated by subtracting. You take the derivative, you just do the first part, 1 over it times the chain rule, derivative of the inside. And then the next one, 1 over it times derivative of the inside. And we're done. That quick. So much nicer. So logs are actually helpful in this situation. There we go.